Today we'll discuss about sampling distributions and estimation. Lot of analysis we keep doing in our software industry with the projects data, and many times we will not be aware of what is prediction, what is forecasting, and what is population, what is a sample. All these terminologies which are very much available in the industry and interchangeably used by people. So let us be clear before starting our analysis what is population and what is a sample. So population is collection of all items of interest in a study. So if we execute 100 projects in an organization, all the 100 projects data is called as population. And if we are eliminating even 4 projects data sets out of this entire population of 100 projects, then there is a possibility that we are eliminating the behavioral aspects of an organization from the analysis. So from that perspective, we call this as a sample only. Whatever the remaining 95 projects or 96 projects that are available data that you are picking it up for analysis is called as sample only. And based on this sample, we are going to predict or do forecasting of the entire organizational behavior. So what is it called as a sample? Sample is a subset to be representative of the population. So we might select 10 projects data out of 100 projects data, or we might select even 85 projects data out of the 100 projects data. Only thing is, when your sample is nearing the population size, what happens is the prediction accuracy will improve. The prediction accuracy of the analysis, whatever we are forecasting or predicting, it will improve a lot. And what is this statistics is all about? It is a number calculated from the sample data. So anything that represents or describes the sample behavior in terms of number is called as statistics. So just for an example, average is called as a statistics. So we would have heard average rainfall in a country, or otherwise average population in a country, population in a year, how much it is, or otherwise average male height in a country. So such kind of statistics are available for each and every country. And this is called as statistics. Statistics is a number which can be calculated from the sample data, and it describes the sample behavior. And then here there are something called as parameters and statistics. So the parameters are related to population and statistics is related to sample. Population parameters are arithmetic descriptions of a population. So mu, sigma, p, sigma square, n are called as population parameters. Mu is nothing than mean of the population. And then sigma is standard deviation of the population. Then P is probability, that is also related to more of a Poisson distribution. It is P, the average of that it is. So sample statistics is arithmetic description of a sample. X bar, small s, P, small s square, and then n. N is the sample, small n is the sample size. X bar is the average value of the sample, and then s is the standard deviation of the sample. That is, so we cannot intermittently or interchangeably use the word mu and x bar, or otherwise mean and x bar, average. Mean is related to population and average is related to sample. Let us be clear about this distinction. And then what we do with the probability distributions. So there is something called as unobservable and then observable. Unobservable is this portion of the entire data sets. So we have for the unobservable and the observable, the descriptive statistics is available, and based on the descriptive statistics available for the observable data, we do the we use probability distributions and give inferential statistics, which is called as unobserved. That is how the differences are. So let us be very clear between the observed and unobserved behavioral patterns. Based on the observed behavioral pattern, we are going to predict or forecast the unobserved behavior. And this is called as inferential statistics. So when because I'm using too many times the difference between using the words prediction and forecast, what is the basic difference between forecast and prediction also? Let us see how it goes. So forecast, I'll just go to another presentation with respect to forecast and prediction. Just hold on for a while. So what is forecast versus prediction? So prediction is about characterizing an expected outcome or expected response based on behavioral parameters or factors on which it is dependent. Whereas a forecast is about characterizing the future value of an expected outcome based on past data of the same parameter. Right? Prediction is based on dependent factors, and forecast is more based on time. That is the major difference between prediction and forecast. So for us to understand more clearly, so let us take some example and see. So predict the productivity of software development based on developer skills, requirements clarity, reuse, etc. So what we are doing here is there is something called productivity of the software developer or otherwise the software project, where we are trying to predict based on our past 100 projects behavior. So what we do here is we take the developer skill of all the 100 projects in all the 100 projects, take the requirements clarity index of all the 100 projects, and then reuse percentage also in all the 100 projects. So based on this parameters and data, what we can do is build a regression equation between productivity and these three parameters and predict the productivity of any other project which is going to come in, and based on what kind of developer skills I have, and what kind of requirements clarity I can expect, and the reuse percentage, how much it might be. So the productivity is being predicted based on these factors, and that can be used for actually our estimations for the project. And whereas in forecast the sales for Q4 based on Q4 sales data of previous years. Here, the only factor that we can see, visualize is the time period. Otherwise, there is no other parameter that we can visualize. But actually, forecast is more robust in comparison to prediction from covering all kinds of environmental factors as well. So here forecast, we are not considering two or three factors which based on which the sales is being predicted. We are covering the entire all kinds of environmental factors which might be even in hundreds in number also, and then we are predicting the forecasting the sales for the Q4 of the next year. Whereas if I want to talk similar thing for sales also from prediction perspective, then I might need to just take something like a sales person skill level, or otherwise what kind of clarity we have about the customer requirements, what kind of geography we are targeting upon. Based on those things also we can predict sales. But that is only we are considering known parameters or known factors, two or three factors. Whereas when it comes to forecast, it can cover the entire environmental factors which can happen. We call it as, in other terms, seasonal. So some of the environmental factors behave seasonal, and based on the seasonal patterns, we forecast the future. This is one thing which we should be very clear about between forecast and prediction. All forecastings can be predictions, but all predictions cannot be forecasting. So forecasting is basically a subset or sub-element of prediction. That is with respect to the forecast and prediction. Hope I'm clear about it. And we will come back to the other presentation, what we are looking from the statistical inferential perspective. Yeah. So, just let me skip some things, okay, and then come to the something called as descriptive statistics here. What we will be learning as far already we have learned it, and again we'll be looking at this once again. So there is something called as descriptive statistics we do based on Anderson-Darling test. We try to understand the as mean value, standard deviation value, and then the skewness kurtosis. Of course, these parameters we don't require to understand at this moment in time, being a non-statistical persons. So let us more understand just what is required for our day-to-day analysis kind of stuff. So we have the average value which is being calculated for the sample, and based on that sample behavior, the sample data set is fitted to a statistical distribution, and based on the statistical distribution parameters, we are going to predict the population behavior, and that population behavior value here is mean. We call this as mean, and then the standard deviation value, and then the variance. And then we have something called as 95% confidence interval also, which is predicted. So what is this 95% confidence interval is? Tomorrow, if we are executing a project and that project value, the 95% of the times, or otherwise 95, I have 95% confidence that it will fall between 6.18 and 6.84, the average value of those projects. So in future, when I'm executing around 20 projects or 25 projects, the average value of those 25 projects will fall between 6.18 and 6.84. And that we are saying with a confidence of 95%. So still there is a possibility that the average value or otherwise the mu value of those 20 projects, I'm now talking as population, those 20 projects data value of mean value can fall beyond these two limits also, but it's only 5% of chances there. That is what we mean by 95% confidence interval here. And then we have something called as even standard deviation also, 95% confidence interval for sigma value as well. So here 95% confidence interval for sigma is nothing than similar to what we are talking about mean value or mu value. Similarly, we are predicting for the standard deviation of those 20 projects data. The standard deviation of those 20 projects data can have a standard deviation value between 0.52 to 1.01. which is very good in nature. If we are seeing that, because we call this as a good value or acceptable value prediction when your mean value and the standard deviation value are related to each other in terms of standard deviation value should never exceed more than 1/3 of the mean value. As long as the standard deviation value is less than 1/3 of the mean value, it's a good data set and good prediction. The accuracy levels can go up. And when it comes to a square, here there is something called as a square value, which is around 0.144. And that is, we accept or we don't accept based on the normality behavior. So if it is less than 0.757, then it is non-normally distributed